Here we have a theorem. If F is a homomorphism of a group G to G prime, then H is a subgroup of G, implies FH is a subgroup of G prime. Let us say that we have a group G. Let this H be a subgroup of G. So we have elements say A, B, identity, C, and so on. And let's say here we have G prime. Then we have FH. We have to prove that this FH is a subgroup of G prime, okay? So the elements in FH will be of the form FA, FB, FE, such that these are the images of these, okay? So let FA be equal to A prime, FB be B prime. Now before proving that this FH is a subgroup of G prime, we will first show that it is a non-empty subset of G prime, okay? If H is a subgroup of G, it means that for A, B belong to H, it implies A, B inverse belongs to H. That's why it is a subgroup because of this. Now in the same way, to show that this FH is a subgroup of G prime, we will take elements A prime, B prime from FH, and we will show that A prime, B prime inverse belongs to FH. If we can show this one, then we can say that FH is a subgroup of G prime, okay? So first we show that FH is a non-empty subset of G prime. Now we come to the proof. If we have element E from this subgroup H, then this one will be mapped to FE, implies the image of FE is E prime. Say this one is E prime, okay? So what does it mean? It means that we have some element here in FH. So therefore FH is a non-empty subset of G prime. Now we finish the first part. Now we will show that FH is a subgroup of G prime by showing that for A prime, B prime belong to FH, A prime, B prime inverse belongs to FH. So let A prime, B prime belong to FH. We will show that A prime, B prime inverse belongs to FH. Now if A prime, B prime belong to FH, it means that the image of A is FA and that of B is FB. So the image of A is A prime and that of B is B prime. Now we take A prime, B prime inverse, okay? What is A prime? It is FA. And what about B prime? It is FB, the whole inverse, okay? For this one, it means FB inverse. Now we already know that this F is a homomorphism. So instead of writing FA, FB inverse, we can write it as FA, B inverse. Why? Since F is a homomorphism. Now we have to show that FAB inverse belongs to FH. If we can show that this one belongs to FH, we can conclude that A prime, B prime inverse belongs to FH. From the beginning, we know that H is a subgroup of G. Since, I mean to say it is H, since H is a subgroup it implies that AB inverse belongs to H for all AB belongs to H. This is the condition to show that any subset is a subgroup of a group G. Okay, so if this is the case, it implies that FAB inverse belongs to FH. That is, the image of AB inverse is in FH. So therefore, if FAB inverse belongs to FH, then from here it implies that A prime, B prime, A prime, B prime, A prime, B prime inverse belongs to FH. Okay, since this is equal to this, then we say that A prime, B prime inverse belongs to FH. Hence, this FH is a subgroup of G prime. Hence, proof. I hope it is clear. Thank you for watching.